Okay, everyone, we're going to be working on some semantic trees. We will work on this sentence. There is an x, gx, and for all y, lyx. So we want to know how to diagram this on a semantic tree. And what we're going to do is we're going to, just to make it a little bit interesting, uh, do this with a two-element domain or an interpretation that has two objects in its universe of discourse. Anytime we diagram a sentence, we draw a tree under a sentence, we always pay attention to what type of sentence that is. And in this case, our sentence is an existential generalization. The existential quantifier is the main logical operator. I'll go ahead and highlight that. And that tells us that since it's a generalization, we need to evaluate its instances. So we're going to draw two branches because we have two objects in the universe of discourse. And on the first side, we're going to form its first instance. And here's how we do that. We drop the quantifier in the outer parentheses, go with it, and we just recopy the entire sentence until we come to the first x, which is the variable of quantification. There's an x inside that quantifier. X follows the letter G. We're going to replace that x with 1. Same with the second x. Then we'll hop over to the second instance, drop the quantifier in outer parens, starting with G. When we come to that x, we're going to replace it with 2. Okay. So, thinking about the second sentence, we have G1 ampersand for all y L y1. This ampersand is the main connective, same as the case over there on the second instance. So we then, what do we do with binary connectives? How do we diagram them? We branch to their component sentences because those are the things that determine the truth value of a truth functional sentence. Don't make this too complicated. Just copy the components the way they are. All right, so we have a conjunction here. We have a G2 on the left side, so G2 goes on the left branch. On the right side, we have for all YL, Y2. For all YL, Y2 goes on the second branch. Our G1 and G2 are logically simple, and what that means is that we will not be drawing any branches under them. But our right-hand branches are both universal generalizations. I'll highlight that quantifier. And that means, of course, that we branch twice because our universe has two objects in it, L11, L21. On this branch, we take Ly2 and we replace the y with 1, L12, and then we replace the y with 2, L22. That's our tree. We don't need to do anything else to it. Now, we may need to determine the truth value of this sentence in a certain way, depending on the problem. Let's suppose that we need this sentence to come out true. Existentials, in order to be true, have to have at least one true instance. All right? It could be the left instance, it could be the right instance. We don't know which one it is. So we can certainly work from the bottom up if we want to. Try to make this come out true. Let's see if we can make this first instance come out true. This first instance is a conjunction. In order for it to be true, it has to have both true conjuncts. That's the rule for the truth functional ampersand. So if our left conjunct is true, that just means G1 is true. If our right conjunct is true, that means for all y, L, y1 is true. The universal generalization is only going to come out true if both of its instances are also true. And what we need to do is, of course, look at these t's that we've assigned on the left-hand branch, the left-hand side of the tree, and see if any of them appears on the right. And they don't. These are all distinct sentences. There's G2, not G1. We have L12 and L22, not L11 and L21. So if we want to, we can put F's under all of those. A universal generalization where both instances are false is a false universal generalization. A conjunction where both conjuncts are false is a false conjunction. We have then our true existential generalization. It has at least one true instance, which is a conjunction. It has both conjuncts true. Though one of those conjuncts is a universal generalization and all of its instances are true. So this works out really well. What we need to do then is come over here and fill out the extensions of our two predicate letters. If we look under the G's, we have as G1 is true, but we see G2 is false. What that means is that 1 is in the extension of G, but 2 isn't. And if we look under the L's, we see that L11 is true and L21 is true. We also see that L12 is false and L22 is false. What that means is that the pair 1, 1 is in the extension of L, and the pair 2, 1 is in the extension of L and nothing else. This is our completed interpretation for this problem. On this interpretation, our sentence comes out true.